Hello, everybody, and not today, in this module, we're going to be talking about the Earth system, and let's start with this word right here. Let's start with the word system. A system is a group of interacting, interrelated, or interdependent parts that together form a whole, which means that the system requires several elements in order for it to work. And in our case, the Earth system consists of these 4 to 5 elements. And we can start with this first one right here, which is called the hydrosphere. Refers to, all the water bodies that are found on the surface of the earth as well as in the subsurface of the earth. And the atmosphere, I'm pretty sure you've heard about this term. This refers to all the air that blankets our planet, and of course we need this to breathe every single time. And the next one, the third one, is the cryosphere, or refers to any ice that are found on the surface of the earth, for example, on Greenland or in the Antarctic in the South Pole. And I have to say that some people like to include cryosphere with hydrosphere, and the reason for that is because both of them are made of the same thing, right? H2O, or water molecule. Okay, the difference is simply ice is the solid phase of H2O, and water is the liquid phase of H2O. And then the next one here is the biosphere, and biosphere refers to any living organisms that are found on the surface of the earth, and that would include vegetation and animals, as well as us, right, humans. And last but not least is the geosphere. And geosphere, well, I have to say this is probably takes a lot of percentage, or it actually, I mean, this course is about environmental geology course, right? So obviously don't be surprised that there will be lots of discussions on the geosphere. Okay, so geosphere refers to the solid earth, okay, the land, okay, that we have on Earth. That would be considered as the geosphere. And let's start with the first one, which is the geosphere. And again, as I mentioned earlier, it refers to solid rocks or solid earth, or rocks, okay, or other types of materials derived from rocks that make up the earth. And I have to say that it is very dynamic, okay. Because the geosphere is dynamic, it creates mountain chains and it opens up ocean basins, and everything here is driven by the Earth's internal heat. Okay, and we're going to be talking about this in more detail when we learn about plate tectonics and continental drift in future modules. And of course, because it is so dynamic, the geosphere would also create hazards that are pretty dangerous to humans, such as volcanoes and earthquakes, right? But at the same time, it also provides substances or things that human needs. For example, mineral resources and energy resources. Okay, so that is geosphere. And for when we learn about geosphere, I'd like to start with the origin of geosphere, or you can say that the origin of the Earth. Okay, so how did the Earth form? Okay, that's the big questions. Well, I have to start with this fact right here, that the Earth is estimated at has about 4.6 billion years of age. Okay, which is pretty old if you ask me. The formation of the Earth. Well, when we learn about the formation of the Earth, we have to learn about the formation of our solar system. Okay, because the formation of solar system allows the Earth to form, and every single objects that we have in our solar system actually form at the same time. Okay, so for example, if I ask you the age to compare the age of Mars and the Earth, well, they're both the same. Okay, 4.6 billion years old, and that's the same case with the sun as well. Okay, the sun would have the same age, which is about 4.6 billion years ago. So my point here is that every object in our solar system has the same age. So the solar system the formation of solar system started out with this immense cloud of gas and debris that we have here in this region, which is called the nebula. Okay, which began to collapse under its own gravity. The reason for that is because there's a big and hot object right here in the center, which would, well, guess what? Which would produce the sun eventually, which has a lot of gravity right here, and everything just collapses under its own gravity, create one bright star right in the middle. And as I mentioned earlier, this would be the region where the sun would form. Okay, and what happened on the outer side of our solar system? Well, in the outer side of the solar system, it consists of debris or space dust, which actually in the form of minerals or rocks. Okay, or not only that, we also have gas and water as well in the outer part of solar system. And because all of these debris, especially the bigger ones, okay, they actually have their own gravitational force. They would attract smaller objects, okay, and they will be attached to it, okay, and these impacts will create heat. So this debris will become heated up, and eventually it would create some sort of like a spherical object, and at the end it will create what we call as planetesimals. Okay, what is planetesimals? Well, you can say it's like a baby planet, okay, or a protoplanet. That will be the technical term for planetesimals. Okay, so the early Earth looks something like this. Okay, like a very hot molten ball of rocks, basically. Okay, and eventually it would create this nice, beautiful of our solar system with the sun at the center part of the solar system, and then we have different types of planets orbiting the sun. Okay, which look something like this, right? So this is the structure of our solar system, and again, our solar system consists of a star, which is called the sun, and then we have other planets that revolve, that go around the sun. And we can actually group these planets into two main groups. The first one is the terrestrial planets, and the second one is called the Jovian planets. As you can see here, the terrestrial planets include these first four planets that we have here that are very close to the sun compared to the other planets, of course. And they are Mercury, Venus, the Earth, and Mars. Okay, and then after that we have the asteroid belt right here that separates the terrestrial planets from the Jovian planets. So these are all Jovian planets right here, including the Jupiter, Saturn, Uranus, and Neptune. Okay, so these are all Jovian planets. Now, what is the main difference here? Well, as you can see there, the size is so different. The first four planets are relatively much smaller than the rest of the Jovian planets. Okay, and the reason for that is because these planets consist of rocky material, so they have their gravitational of these rocky materials basically allow them to coalesce into much smaller planets. Okay, and terrestrial planet consists of rocks. Okay, so these are rocky planets for terrestrial planets, whereas Jovian planets, they are mostly gas. Okay, so those are the two main differences, okay, between terrestrial and Jovian planets. All right, so just to give you a brief introduction to the geosphere. This is the structure of the Earth, and when we learn about the geosphere, we have to learn about what's going on inside the Earth as well. And I have to say that it's a easy concept actually to digest. In order to differentiate the Earth's interior layers, we need to learn about the two main things or two main criteria to classify the Earth's interior. The first one is based on the chemical composition, and the second one is about the physical properties of these layers. So let's start with the first one. So based on chemical composition, the Earth can be divided into three layers. From top to the center is the crust, the mantle, and the core. Okay, because we divide these layers based on their chemistry, so we need to know what kind of elements, chemical elements, that make up these layers. For the crust, it is mostly silicon and oxygen, whereas the core, it is mostly iron and nickel and some other types of metal as well. What about the mantle? The mantle is literally just a mixture between the two. Okay, so it does have some silicon and oxygen, but it also has a bunch of metal elements as well. If we start with the crust, there are two main types of crust. The first one is called the continental crust, and the other one is the oceanic crust. Okay, if you imagine the cross section from New Jersey, for example, if this is New Jersey right there, and then if you travel to the east, then you will eventually end up in Jersey Shore. And then here, the rest of this area right here would be the Atlantic Ocean, right? So here is a nice illustration, and it actually shows you the differences between continental crust and oceanic crust right here. The continental crust is much thicker than the oceanic crust. That's something that we can directly observe based on this diagram. But there are some other differences as well, as I'm going to tell you in the next few slides. Okay, so for the continental crust, the composition is mostly made of silicon and oxygen. Well, you can say aluminum as well as a third chemical element that is pretty abundant in the continental crust, and it's actually pretty thick. As I mentioned earlier, it goes up to 70 kilometers, but in average it would be 40 to 50 kilometers in thickness. And within that 40 to 70 kilometer, you can actually fit at about 100 to 150 Empire State Buildings within the continental crust. So it's quite thick. Okay, and what kind of rocks that we have in the continental crust? This will be the type of rocks, which is called granite. Okay, so well, you've probably heard about granite countertops. Okay. Well, it may not necessarily be granite, but granite is, in geology, is referred to a certain type of rocks that make up the continental crust, and it is mostly, light in color. As you can see here, there are some light areas right here. There's a lot of them, but there are some black specks as well, and we're going to learn that when we learn about the geosphere materials later on. And what about the oceanic crust? Well, the oceanic crust, because it is the crust, so it does have some silicon and oxygen as well, but the oceanic crust is kind of different. It actually has much more iron and magnesium, and these are metallic elements, so there are a lot more metal elements within the oceanic crust. Okay, and the thickness is actually much thinner than the continental crust. So in the continental crust, we can fit about 100 to 150 Empire State Buildings, but in the oceanic crust, we can only fit at about 11 to 18 Empire State Buildings. So it's much thinner than the continental crust. Okay, and the type of rocks is basalt, and as you can see here, the basalt looks so much different from the granite picture that I've already shown you before. Basalt is a type of igneous rock that looks very dark in color. Okay, and the reason why it gets dark in color is because of the presence of these metal elements within the rocks, which is iron and magnesium mostly. Okay, so this slide, just to summarize the differences between continental crust and oceanic crust. And again, because the oceanic crust has a lot more iron and magnesium, so therefore it becomes much denser than the continental crust. Okay, and again, some other differences will be the thickness, as well as the composition is slightly different, and as well as the type of rocks that are produced within the each type of crust. So that was just for the crust, which is the thinnest part of the earth, in the outermost part of the earth, right? What about the mantle? The mantle is probably the thickest part of the earth based on its composition. It goes up to 2,900 kilometer, and you can fit about 6,500 Empire State Buildings. And again, if it's hard for you to imagine that you travel from New Jersey in a direct path like this all the way to Denver, Colorado, and that would be, the representation of the mantle thickness of the earth. Look at that. Okay, so it's very, very thick. And what about the rocks that we have in the mantle? Well, the rocks in the mantle looks very green. Okay, and the name of the rock is called the peridotite. Okay, the peridotite typically consists of these olive or green minerals that you see here in this picture right here. Okay, and they are made of they make the mantle. Okay, so if I were to redraft this diagram, I would change these red colors into green colors, because that's what the color of the mantle is. Okay, and what about the core? The core is made of, again, mostly metal elements such as iron and nickels. Okay, and it is very hot at about 6,000 degrees Celsius, and 6,000 degrees Celsius is about the same temperature of the sun's surface. Okay, and the depth is down to 6,371 kilometer, and that would represent the radius of the earth, right? Okay, so the depth from the surface all the way to the center part of the earth is about 6,300 kilometer. Now, that was the division of the earth's interior based on chemistry or chemical composition. Okay, now, as I mentioned earlier, that we also have the second criteria, which is the physical properties. Okay, so we can also divide these Earth's layers based on, or these Earth's interior based on their physical properties. Okay, so again, here is the Earth, and here on the left side, that you're seeing the compositional layers, and as I mentioned earlier, that we have the crust and the mantle and the core. Very, very, very simple divisions right there. For mechanical layers, or the physical, based on physical properties, it's also very simple actually. We would have the lithosphere, the asthenosphere, mesosphere, and the outer and the inner core. Okay, so we're going to take a look at each of them in the next few slides. Well, I have to say here that the lithosphere, here, as you can see in this illustration right here, the lithosphere right here, it actually covers the entire crust. Okay, the entire crust plus the upper part of the mantle. Okay, so that's basically the definition of the lithosphere right there. Okay, and as I mentioned earlier, that is what I just said right there. It covers the entire crust and the upper section of the mantle, and that would represent the lithosphere. Okay, the lithosphere is the outermost layer of the earth based on the physical properties, and it is very rigid, solid, and strong. Okay, again, we're not talking about chemical composition anymore when we talk about the lithosphere. We're actually just talking about how strong they are, what is the temperature, what is it solid or is it liquidy, things like that. Okay, and the lithosphere is pretty cold compared to the other layers of the earth underneath it, and as I mentioned, it covers the entire crust and the upper part of the mantle. The similar thing with the crust. The lithosphere also consists of two types: the continental lithosphere and the oceanic lithosphere. As you can see here, this is the continental lithosphere right there, and the oceanic lithosphere right here is again thinner than the continental lithosphere. Okay, so basically the type of lithosphere is driven by what type of crust that we have on the surface of the Earth. Okay, and then the next one is the asthenosphere. The asthenosphere is the hot layers, so high temperature, that underlies the lithosphere. Okay, and the asthenosphere consists of molten rocks. Because it is molten rocks, because it consists of molten rocks, so it becomes weak and plastic, and it is able to flow because it has some viscosity properties in it. Okay. And then the next one here is the core. Okay, so we have the core, and based on its physical properties, we can actually subdivide the core into two sub parts. Excuse me. The first one is the outer core, and the second one is the inner core. The outer core is the liquid part of the core, and the inner core is the solid part of the core. So that's something that I want you to remember. And again, here is the liquid iron, and here it actually has some sulfur in it. So this iron and sulfur is so liquidy, it is able to flow and flow and flow, blanketing the inner part of the core that consists of the solid iron. Okay, so I guess that's what it is for this video. And in this video we just talk about the geosphere, and in the next video we're going to be talking a little bit about other types of spheres that make up the Earth system. And I'll see you in that video. Okay, bye bye now.